Think about this. How do you know that the period is over without even looking at the clock? Easy. The school bell rings, and at once your brain says, class over. When someone knocks at your door, when your phone ringtone starts, when mom calls you from the kitchen, you don't need to see anything. You just hear the sound and understand the message. So today, in Class 10 Physics, let's understand, what is sound? How is it made? And how does it reach our ears? First big idea, sound is always produced by something that is vibrating. Look at this bell. When it is silent, it is still. When we hit it, ting, the metal starts shaking very fast. This fast back and forth motion is called a vibration or oscillation. Whenever something vibrates, a bell, a guitar string, a rubber band, even your vocal cords, it pushes the air around it again and again. That push travels to our ear as sound. Let's take a few easy examples. When you pluck a rubber band, it moves to and fro very fast, and you hear a twang sound. When you hit a hanging metal plate with a spoon, it starts shaking. If you touch it gently, you can feel those vibrations. And when the plate stops vibrating, the sound also stops. So remember this rule: no vibration, no sound. Every sound you ever hear, music, voice, noise, starts with some object vibrating. Okay, now second big idea. Sound has to travel from the source to your ear. But how? Sound travels as a wave. The vibrating object pushes the particles of the medium, like air, water, or a solid. In air, particles move closer and apart, making compressions and rarefactions. In water, sound travels as ripples through the water particles. In solids, the particles are tightly packed, so sound can actually travel even faster. If there is no medium, no air, no water, nothing, then the sound wave has nothing to push. That's why sound cannot travel in a vacuum. In space, if an astronaut shouts without radio, no one can hear anything, because there is no air to carry the sound. Now, how does your body catch these sound waves? Your ear is like a smart sensor. The outer part of the ear collects sound. The waves move inside a small canal and hit a thin skin called the eardrum. The eardrum starts vibrating when sound waves hit it. These vibrations are passed into the inner ear, converted into electrical signals, and sent to your brain. Your brain then says, "Oh, that's the school bell. That's Ma's voice. That's my favorite song." So basically, vibrations outside, vibrations in eardrum, brain understands sound. Now let's talk about loudness. Why some sounds are soft and some are very loud. Loudness mainly depends on amplitude. Amplitude means how big the vibration is. Small vibration, small amplitude, soft sound. Big vibration, large amplitude, loud sound. So when you hit a glass gently, the sound is soft. When you hit it hard, it vibrates more, so the sound is louder. In physics, loudness is measured in a unit called decibel, written as dB. Very loud sounds, above around 80 dB, can actually be harmful to our ears. Next, pitch. This tells us whether a sound is high or low. Pitch depends on frequency. Frequency means how many vibrations happen in 1 second. It is measured in hertz, written as Hz. High frequency, many vibrations per second, high-pitched sound, like a whistle or a small child's voice. Low frequency, fewer vibrations per second, low-pitched sound, like a drum or a man's deep voice. So if you say, her voice is very sharp, you're actually saying her voice has high pitch and high frequency. And when you say his voice is heavy, that means low pitch, low frequency. Have you ever shouted hello near a big empty hall or in the mountains and heard the same word coming back after a moment? That returning sound is called an echo. Why does it happen? Because sound can reflect. It bounces back from a hard surface, just like light reflects from a mirror. You will learn more how this reflection creates echoes, how it can cause reverberation in big halls, and how we use this idea in sonar and ultrasound machines in science and technology. Let's quickly revise. 1. Sound is produced by vibrations. Bell, string, vocal cords, all must vibrate. 2. Sound needs a medium to travel. It can move through solids, liquids, and gases, but not through a vacuum. 3. We hear sound because our eardrum vibrates, and the brain understands those vibrations as sound. 4. Loudness depends on amplitude. Big vibrations, loud sound, small vibrations, soft sound. 5. Pitch depends on frequency. More vibrations per second, high pitch. Fewer vibrations per second, low pitch. If you understand just these 5 points clearly, you have already understood the heart of the sound chapter.